Welcome back to my channel. Today we are going to be doing this identity, which is 5.1.1. Let me just take it down first. We're having tan divided by, so we're having this one. So how do you then reduce these big angles? First of all, 408 is beyond the first revolution or the cycle. So you can just say 480 minus the first cycle, which is 360. You will get the reduced angle, which is not complete, to be 120. So for this one, it can change to be just 120. This is just the very same quadrant, the very same thing. Now 300, we can reduce 300 to the reference angle, because 360 minus what to get 300. So this is 360, this is 360, this is 360 minus 60, so to get this one. But sine 300 is in which quadrant? Fourth quadrant, where sine is negative, so we are having that negative there. Then let's come to this one. We can't change this one. Sine 14, we really don't have any relationship about this angle because it's really not a special angle. Now let's come to this one, times when you are having negative angles, normalize to just add 360 there. So we're having negative 135 plus 360 to get the positive what? The positive angle, which is 225. So when you are having sine 225 there, so we are having that one, let's divide by, then we are having sine 104. 104 is made by 180 minus what? Minus 76. So we are having sine 180 minus 76, which is going to be just sine 76, because we are just reducing the angles. Now this one, it can be reduced to 225 is do belong to 045, but we are going to be dealing with that. Then of course, which means it's going to be negative cos 45. Cos 45. So we have this now, which is not completely reduced, because we still have 120 here, we still have 225 that side. So let's just quickly reduce this one. So 120 is 180 minus 60, so to get that one. So we are having 120 is on the second quadrant where tan is negative, so we are having negative tan 60 now, then times negative sine 60 times cos 14 times sine, let's remember that quadrant 225 is on the third quadrant where sine is negative, so we'll be having negative sine 45, then all divided by, then we can't do anything to this 76, then 225, we have already changed, this is just negative cos 45. So we are having these kind of things now. What do? We need to apply our knowledge about these special angles, that if you are having 30 here, this is 60 here, this is 1, this is 2, this is root 3. Then for the other one, which is 45, we are having, we have 1, we have root 2 for 45, and 45 that side, if this is right angled triangle. Now we are looking for tan 60. Tan 60 is opposite over HSN, which is just 1 over which is root 3 over 1, which is just gonna be negative root 3 over 1. 1 doesn't matter. Now let's come to sine 60. Sine 60 is opposite over hypotenuse, which means we are having root 3 divided by 2, then times, let's come to sine 14. Sine 14, what can we do about that? Cos 14, then times, this is not 44, this is 45, I'm sorry. Then we are having this 45 is opposite over hypotenuse, so this is going to be just negative 1 over root 2. So we are done with the numerator. Let's come to the denominator now. Let's just put this as it is, times cos 45. Cos 45, which is going to be having negative 1 over root 2. So things that are cancelling each other, we shall just do that. Now what are we having? Oh, sine cos 14 and sine 76, these are the core functions, so they can cancel each other, because remember 14 plus 76 is equal to 90. So if these angles are in different trig ratios and the other one is on top and the other one is on the bottom, since they are equal to each other, then they can just cancel each other. They just give us 1. Then this one, together with their negatives, they cancel each other, no story. Then therefore, what are we having as a remainder? We're left with negative this times that. So negative root 3 times root 3 is just gonna be 3, then over 2. So this is just gonna be the answer. So we really did prove that the left hand side is equal to the right hand side. So this is just 3 over 2. Done. Now let's come to the second question. The second question, let me just rub this whole thing. Let me rub this whole thing. The second question asks you to prove that. It asks to prove that cos 75 is equal to root 2 into root 3 minus 1 all over 4. So how do you go about doing that one? The first thing is to remember that 75 is made of some special angles that are adding each other. So when you are having 75, you probably have 13 plus 45, which is just going to be something like that. 75 is made of 30 plus 40 plus 45. So this is 75. So we just need to remember now, how do you then expand this compound angle, of course, which is equal to cos 30 cos 45. Then remember the sign changes kubani cos. Then we have sine 30 sine 45. So this is what we have now. Then would cos 30, we need to use this thing. You have 60 there. Then we have 1, you have 2 there, you have root 3. So cos 30 is adjacent over hypotenuse, which is root 3 over 2, then times cos 45 is just 1 over root 2, then minus sine 30 is just 1/2, then times 1 over root 2. So this is what you have so far. Then the idea is to simplify it further. So what are you having? You have root 3 times 1. This is just root 3 divided by 2 root 2. Then minus negative 1 times 1. This is just 1. Then 2 root 2. So this is what you have. So if the denominators are the same, then you can just take one denominator and add the numerators. So this is what you have so far. But remember what we are proving. We have to prove that it is equal to that. So let's just try to rationalize. Let's multiply it by root 2 both sides, to both sides, up and down. Then what are we going to be having now? We'll be having root 3 times root 2, which is going to be root 6. Then negative 1 times root 2, which is negative root 2. Then all divided by, then 2 root 2 times root 2, which is just going to be 2 times 2, which is just 4. So are we not close by? No, we just need to simplify to factorize further. So this one, we know that root 6 is made of root 3 times root 2, then minus root 2 then all over 4. So we can factor out root 2 to get root 2, then you get root 3 minus 1, then all the way to get 4 in the denominator. So we did the proof that way, that the left hand side is indeed equal to the right hand side. So that is how you approach these kind of things. When you are having this 75, make sure that you take, there is the combination of special angles. So here we have taken 30 plus 45. That's the idea. We do what special whose special angles they added or subtracted each other to get that number. Like for example, you can even be asked to find 15, which means 45 minus 30. Then if you expand your what, your compound angle, then done for 5.1.2. So let's then come to number 5.2 now. I hope you're still with me. 5.2. We are to prove that this side is equal to that one. 6 marks. So let's prove that that one. The idea is to start with the left hand side. The left hand side, let's just deal with the left hand side. We are having cos 90 minus 2x. Let's just reduce that angle because the idea is to note that 90 minus, you change the trig function. Now we'll be having just sine 2x right then. Then times, let's come to this one. 180 plus is in which quadrant? Was third quadrant, where tan is positive. So we'll just have tan x there. Then you have plus. Then 360 minus is in which quadrant? Fourth quadrant. So yes. Then if it is fourth quadrant, what is the sign of sine there? It's negative. So you are having negative sine x, but remember that squared. Now this is what you have so far, but remember, when the number is being squared, it really doesn't matter which quadrant is it found. The fact that it is being squared, it is always going to be positive. But I just wanted to show you that this is where the negative is, and this is how the square is denoted. Otherwise, if you put it here, you will sometimes assume that it doesn't really affect that negative. It does. That is why I have to just put it there, so that this whole thing becomes positive as an effect of that being squared. Now let's then continue. We change things that are changeable, and you can see that on the right hand side we really don't have tan, even the sine 2x. So we need to change things that you don't see on the right hand side. Now what are we having? Sine 2x is the double angle of what? Of sine. That can be changed to be sine 2 sine x cos x, and tan can be changed to be sine x over cos x. Then therefore this one, I conclude that it is just positive sine squared x. Then we can see that these ones, they do cancel each other. Then therefore we are left with what? We are left with just 2 sine squared x plus sine squared x. These are like terms. They are just equal to 3 sine squared x. Then therefore the left hand side is indeed equal to the right hand side. Done. So thank you for watching. See you in the next video.